Hey guys, welcome back, and let's continue with the next part. Today would be finally the last class for cryptography. We already go very deep dive into this topic of cryptography as if you compare with the agenda and the plan we have planned for this program, right? So, what's the plan for today? Today, I'm going to show you one use case. That's what we are building this entire PKI till date. Okay. So use case would be something like this. And some of the part of the use case I already built in my last class, right? So what I'm going to build today, we are going to launch one web server. Okay. Web server, not your choice, how you want to launch this web server, which product you want to use, or it may be your load balancer also, depend upon which product you want to use. For load balancer, you can use HF proxy. For web server, you can use HTTPD from the Apache. There will be anything, right? So today I'm going to launch a web server in my case. Okay, and you guys know mostly either you talk about load balancer or the web server. Whenever the client, let me put the client over here. So whenever the client hit to your load balancer or to the web server, okay, mostly they will use to connect you to access your website or web app, and they use HTTP as a protocol. And I show you in my cryptography initial classes that if you use HTTP, every data will go in the plain text, and your data can break within a second. So plan is, I would like to configure my web server or the load balancer, okay, in such a way that they start supporting SSL or start supporting TLS, right? In my last class, I told you TLS is a newer version, SSL is an older version, but this is how we normally say. So if you heard anytime SSL, mostly we talk about TLS only. If you talk about SSL TLS, mostly we talk about TLS only. This is not what we use in today's world. We always use, and mostly we always use TLS, either version 1.2 or 1.1, or nowadays we have 1.3 also come up. Okay, so we will implement SSL TLS in my web server or in the load balancer, right? In such a way, what they give you TLS, what the TLS will give you. With help of TLS, now the communication between the server and the client will go in pure encrypted way. Means instead of HTTP, and client will use HTTPS, secure communication, or I can say SSL or TLS communication, what we want to perform today. Okay. So what I'm going to do, I'm going to launch one of my server. In this case, I'm going to launch Apache web server in my one of my Linux instance. Okay, Linux instance, and I want my web server start supporting encryption. And you guys know, for the encryption, okay, what we need, we have to set up public key infrastructure. What are this? In my last class, I will explain you very in detail. I don't want to explain you again. Or what my requirement would be, in my web server, I need my server private key. Okay, and plus I also need my server CSR, certificate request. CSR, actually, it's not CRS. Certificate signing request. And what this certificate signing request contain, I told you, it contains the company information plus the public key of the server. So this certificate my server will create, okay, of my company. Let's say my company name is Linux World. So Linux World will create the certificate, okay, and then send the certificate to the CA. That is called certificate authority. Okay, certificate authority. So we will send the certificate to CA, to their computers. They will verify your certificate, and there's a 2 or 3 way to verification, either by email verification or domain DNS verification, or they come physical verification. What are the way you opt for, or you pay for, whatever they do the verification. And after you have been verified, you have been given back a signed certificate by the CA. Okay, or I can say they will sign this certificate. This is called digital signature. They will do it. Is also mostly will look like a stamp. Okay, and this certificate is known as CRT, and typically this is also known as only the certificate. Certification, the certificate. Okay, and this certificate is the one who that is being kept by your web server. Why? Because whenever the client come first time over the HTTPS, because client want, I would like to use HTTPS communication, your server has to first provide them the server certificate. This is called CRT, server certificate. And what client will take from the server certificate? First, client will check the certificate is valid or not. For checking the validity, if somebody has not interpolated or tempered this information right, they will check the CA sign on it, and they verify the CA sign. Okay, and after sign being verified, then they will get the server public key, because certificate contain public key of the server. And from this, where the CA get the server public key? From the CSR, because when the server create CSR, it contains company information, plus it also contains server public key. That is the main thing we want to use. Okay, CA sign it. So the CRT, what the CRT contain? The server public key, server company information, and the CSR for signature. Okay, so same certificate, this is called CRT certificate. Okay, is being given to client. Client will first verify CA signature. If the signature is right, okay, is right, they will find, the client come to know nobody has impersonate or nobody has tempered the server public key. Means what is public key I am getting is actually the real public key of the company, let's say Linux world. Now client will take this public key and use this public key for further encryption and decryption. That course I already told you. Further communication, client will create their own symmetric key and give a public key, send to server, server use their private key to decrypt, and both have the same symmetric key or share key to do the further encryption. That part I already explained to you. This process is known as TLS handshaking or SSL TLS handshaking. Okay, only challenge in this process is, okay, how client can verify CA signature. Okay, how client can verify CA signature? Because to verify CA signature, client need CA public key, and this CA maybe belongs to my own company. They are not the famous CA or trustworthy CA. Okay, so I'm the expert company. I might create my own personal CA and sign my own certificate. Okay, so I know my CA, but my client on the mobile phone and the browser, they don't know anything about the CA. It means they are not trusting CA. Trusting means they don't have a CA public key in their, let's say, in the browser or in the operating system. Okay, so they don't trust on so that without the public key, they won't able to verify the signature. Because I told you my digital signature class is, if you want to verify the signature, you need that particular public key. And because they don't have public key, they won't able to verify, means they don't trust on this seal. And without trust, they won't take my public key or the server public key. For this, what we have to do, we have to check, okay, your client believe on which CAs. And mostly all the client believes on the root CAs, the top level CAs in the world. I think 5, 10, 20 CAs we have. Okay, so what you have to do, okay, whichever CA you created, okay, you have to take the approval from the root CA. That I am a CA of Linux world, for example, or maybe from XYZ other company, for example, are you giving me approval that I can sign some certificates on your behalf? You're the root CA. For example, your CA may be GoDaddy, for example. The root CA. Okay. So are you giving me approval or authority? I can say that from your behalf, I can sign some certificate. Okay. I can sign it. And why I want to you take approval from you? Because you are the root and all the client browser believe you. Okay. So any signature signed by, let's say, Linux World CA. And I told you guys my last class, this CA also known as intermediate CA or the sub CAs. Okay. So if any certificate signed by sub CA, because the sub CA has been approved by root CAs. Okay. And guys, you know, this concept is called chaining. So we have root CA, then sub CA, and some more sub CAs. So because we have this complete chain. Okay. And this complete chain, anybody who signed the certificate, your client can believe on it. They trust on it. Okay. So this is what PK infrastructure, the public key infrastructure we have. And this concept I explained you in very detail in my last class. But today what I'm going to build, okay, I'm going to build this part. The first part we have to build is root CA. Second part we have to build sub CA. Then third part we have to build the web server. And fourth part we have to build that secure the web server with HTTPS. Okay, this is what we have to do. And because we are going to create our own root CA, there's not like GoDaddy or Digis or something like this. Okay, so we have to ask my client that now we have one more root CA. So your browser, your app, your operating system should know this root CA also, so that anybody signed by the root CA or their sub CAs, you can verify it and you will believe on these stamps or signature. So you can take the public key and do the further communications very easily. So these are 5 steps we have to do today. But this entire concept I'm showing you right now has been already explained by me in my last class in very, very detail. Today I'm going to show you this thing in practically. One part, guys, we already did practically in my last class is this part. So root C, guys, we have already created my last class. So I don't want to waste the time again to explain you this concept. I'm directly going to the step number 2, where I'm going to create a sub CA. This is called intermediate CA. But what is CA, you guys know already. So let me start my instance. Okay, I don't remember my instance name. My instance name may be, I don't know what name I have given. Maybe this one. Crypto, I believe. Format. I don't know which one I created. Maybe entire PKI. Okay. Cryptography and Security. Anybody remember this name? You can put in the chat box, please. What is the instance I created in the last class? Okay, so we can actually jump to that instance only. As entire PK somebody suggested. Thank you very much. So 1 minute. This one. So let me launch, and here, guys, I think this instance I started with the 1 minute. So let me start this instance. Okay. So this instance, guys, we are going to use for doing the remaining part, right? And I think in my last class I used Red Hat version 8 to launch this OS. I think this is the same OS we have to use. Okay, so this instance is running. Okay, and now what we are going to do, typically in the real world, root C is a different company running in a different computer. Sub C is running in a different computer. Your server obviously running in a different computer. But do our practical very quickly. Okay, I'm going to launch root CA, sub CA, and server in the same computer. Okay, but to give you a differentiation, I'm going to create a multiple folders. So one folder, different folder for root CA, other folder for sub CA, other folder for server. Okay. Otherwise, in the real world, all the things will be created in a different computer, managed by different team or different companies. Okay. So this is one of my operating system. Let me take my operating system, open my git bash command line terminal. Okay. Let me go to my download folder. This may be the IP system to connect. Okay. Now this has been connected. And so in my last class, guys, I believe I have created one folder and name of the folder is PKI. Inside this folder, I created this folder root CA. Okay. And root CA, guys, is a root. Okay. And there's nobody typically in the top of root CA. So root CA can create their own certificate. This called CSR. And from CSR, they can create their own final certificate for CRT. And who will sign? Okay, they sign by same CA only. That is called self-signed. So this is the only thing you see in the root CA. They always do their own signature because typically there is no meaning of anybody on the top of root CA. This part we have already done. So if you see the root CA folder, so here we have created a search folder, and this is a root CA certificate, and it's been always signed. How I know? If you're in the open SSL command, and the certificate normally into the format called X509. And if you see input from this certificate and try to convert into text format, okay, text format. Okay, so this is actual certificate. We convert in text format, and this format, guys, this format is the one that is being used in the certificate. Okay, and this format is known as X509 format. Okay, in this format, what you will see that this certificate is issued to this company. Okay, and issued to this company and issued by this. Here you see, okay, normally the two different CAs or two different server is been differentiated by the common name, and here both the name are same. See, and I told you in my last class, everybody will give a different name or unique name, and this name is mostly your DNS name and domain name. Okay, so if you see here, the subject means to whom we issue the certificate. Issuer is one who issue the certificate. Both the name is same. Okay, because this is what you always see in the root CA. Root CA is the one who signed their own certificates. This goes self-signed. But in the sub CA, you will see the difference. In sub CA, the subject would be sub CA, but issuer would be the root CA. So this will be the issuer, and this will be the subject. Similarly, in a web server, the subject would be your web server, but issued by your intermediate CA. Okay, they are the one issue means who are going to sign. By the root CA, it will be always same. Okay, and this is a public key of the certificate that's now is not important right now. So this is what we have done in my last class. I don't want to elaborate the commands to you, but almost the same command is going to repeat today. Almost the same command. A little bit of extra concept going to come up. So I'm going to start the step number 2. Step number 1 is done. Step number 2 is going to start. Okay, and I'm going to create a sub CA, and for this I'll go out from this folder. From this folder, I'm inside this folder. We have this folder. I'm going to create one more folder called sub CA. Okay, and in this folder, typically root CA will create a different folder managed by a different company. This is created by different server managed by a different company or different team. I'm creating both the folder in the same system to quickly do our demo. Okay, so sub CA right now is empty. So one thing, because if you are a CA or server, it doesn't matter. The thing that differentiates you is your private keys. So if you're sub CA, you have to first create your private key. And private key, guys, normally we try to manage a different folder. So I'm going to create a folder called private. Okay, I'm here in the subca folder. There's a private folder for the subca, and I'm going to create a private key. Okay, this is all the command you use. We can also encrypt the private key locally. Okay, I'm going to store the private key in the folder file called subca.key. You can give any name, and maybe this is the key size. This command we have seen multiple times. Here, we're going to store the private key of subca of this size, and this key is stored clear text, but I would have to encrypt with AES with some password. Okay, here the password I'm using Red Hat, but obviously we have to give a very big password and complex password. This key has been created. Now, what is the use of this key? This is the unique identity of your subca. Obviously, this key subca will never going to share to anyone. Okay, let me come out. So this folder contain only one folder called private. But because you are going to become a CA, okay, like a root CA, but you are a sub CA, but normally working is same like a root CA. Okay, so to become a CA, you need a configuration file. Okay, so and in the configuration file, we have to do some changes according to you. So I'm going to create one configuration file from one folder. Okay, and that has already been created in our system. And this file is this one. I'm going to copy in the same location here. Okay, so this is the configuration file for this CA. Root CA has their own other configuration file that I copy from here, and whatever thing you want to change, you can change in this file. So I'm a sub CA. In my root directory, I have a private key plus my own configuration file. Okay. Now what you have to do? Okay, you have to what I say in your sorry, from your CA files, what to do we'll see in a minute. But first thing you have to do is you have to create your own CSR. Okay, so I'm going to create my own CSR. I'm a sub CA. Okay, I'm a sub CA. I'm going to create my own request certificate. But this time I'm going to send this request certificate to the root CA, because this CA has been known by everyone in the world. And I'm asking the root CA, can you please sign this certificate and give back me a CRT? Okay. And because I'm going to take a sign from root CA is by known by everyone. Okay. It means my certificate, I'm a sub CA, my certificate is signed by root CA. So it means my certificate get a validity or authority. Depend what they sign in my certificate. Okay. Accordingly, accordingly, I will get the validity. So what I mean by this? Okay. So let me first create the CSR certificate for my CA. Okay, the command will be again the same, open SSL. Okay, I'm going to create a request certificate. Okay, it will be a new certificate, and for creating a certificate or the request CSR, I need my own private key. Why private key? Because private key is the one who will help me to create my unique public key. Okay, and here I'm going to create a certificate signature in SHA 556 hash format, and I want to out this certificate. Okay, in a folder. You can give any folder name where you want to keep your certificate. Mostly we keep the certificate in the certs folder. Okay, and with the name called as a sub ca.csr. Okay, or let me keep here. It doesn't matter, in the same folder. CSR. So this is what the certificate we are going to create. Okay, and here I'm going to use my own config file, even though we don't require right now for this config file, because this config file we use when you work as CA to sign other certificates. Right now you're on like a normal computer, you're only requesting for a certificate. Okay, so just basic settings. So this is what the command we use. Okay, so this command is for CSR. When I hit enter, Okay, because your private key has been logged. So I will unlock this private key or decrypt this private key so I can create a public key. Now they're asking some details here. So you're creating your own CSR. Who is creating? Your sub CA is creating. Okay, the CSR. So I'm giving my country name, my state, let's say Rajasthan, my city name, let's say Jaipur, my company name, let's say Linux World, my unit may be technical department, my common name, mostly we give our domain name, but here I'm giving a sub CA is my common name. In the root, certificate I given the root CA, but here I'm giving a sub CA or the intimate CA. Emeritus we don't require, enter it. That's all. Okay, so this certificate has been created, but the certificate has no use. Only thing that this certificate contain, we have to open the certificate is in the encoded format. Okay, but we want to read this certificate, again open SSL, because this format certificate into the request format CSR. So I'll take the input from the certificate and try to convert to text format. Okay, where I don't want to see this output, so we can say no out. Okay, so right now, if any CSR certificate, if you have to try to see, okay, CSR certificate only contain mean two things, only the subject, that I am a request certificate by sub CA, and this certificate is not yet signed, so there is no issuer of this certificate, and plus the certificate contain public key. That's all. So two main things this certificate contain. Okay, now even though you are CA, but you are not the famous CA, maybe you are your own company internal CA, you want any certificate signed by you, okay, has been validated to everybody in the world. So for this, you have to first get a signed from the root C. Okay, then it means your certificate have to convert into CRT format. Okay, CRT format. So here, this certificate guys has been signed by root C. So in the real world, your root CA, maybe if you start to search your CA or root CA name on certificates, you can find lots of CAs available. You can go and sign by these guys. Mostly they charge, or they have to partner with them. That's the formality you have to perform. There's a different point. So there's a lot of root CAs available. Okay, some of the name I'll show you already, but some of the names you can find in this kind of websites. Okay, like DigiCerts or like GoDaddy and other CA. And this website will show you who is the current CAs and who expired root CAs, the different point. Okay, so you can see from official sites or from the government websites. But in my case, our root CA, because we have created, so we can sign without any charge. We can sign freely without any cost. So we have to sign, but guys, understand one thing: CA can sign two different kind of certificate. Any CA, doesn't matter root CA or the sub CA, they can sign a certificate, and after the sign the certificate become a CRT certificates. Chinese reminder theorem is what Intel protocol they use, okay, or the algorithm they use, but this was CRT certificates. So either they sign for the AND purpose or AND uses. So do you want to use the certificate for web server, for mail server, for LDAP server, for databases? And purpose means you want to use finally in your server, or they are signing the certificate for sub-CAs. So sub-CAs has no their own purpose. They are not using this certificate, right, for their server or the databases or the mail server. Okay, sub-CA need a CRT. They're signed by this CA, that's called root CA, for example, for in a way that the sub-CA can also work like a CA. Okay, and they can sign some other certificates. Again, the same loop. They can sign the other certificate for next CAs, or let's go sub CAs, or they sign for the servers. Again, this sub CA that's signed by this CA can again work as a real CA. They can again use this CA for signing the other server certificate like web server or load balancers, or to sign some other CAs. This was sub CAs. So like it's a chain. There is known as chain of the CAs, chain concept. Okay, but your root CA can decide. Okay, while signing, if root CA is signing sub CAs, so they can decide how long the chain can be. Okay, so sub CA can create one more sub CA. This is can create one more sub CA. How long the chain could be? This is called path. This is called path length. So your root CA say, I'm going to sign you. You become a CA. You can work like a CA. Okay, so there's a one property I will enable you. Are you CA? I say yes. True. This is one property I enable for you. Okay, that's property make you CA. So you can sign a CA. So you can sign for other servers and sub CAs to create more sub CAs. Okay, but after you, can you create one more sub CA? Or after you, I don't allow you to create some more sub CA under you. Okay, means how long a chain will work, it will decide by path length. So if I give the path length 1, okay, so this root CSA, okay, while creating a CRT, if I set the path length 1, it means under you can create one more sub CA. But thus this sub CA can't create more sub CAs. But if you give the path length 0, means under you, because this is your certificate, under you, you won't able to create more sub CAs. Only use that you have is you work like a CA that you can only sign the servers certificates. There's end user certificates or end server certificates. Okay, so path length 0, 1, this is the one through which we can control the chain. Plus CA true and false is a concept through which we make somebody certificate work as CA. For example, if this root CA signed this end purpose certificate, again this is a CRT only, but here they make CA colon false. I mean, this certificate is only used for server purpose. They are not working as a CA purpose. This server, this guy won't able to sign some other one. So there are multiple properties we have. This is also known as attributes we have. CA false means this certificate is only used for server. CA true means this certificate only used for becoming CA. Path length 0, 1, 2, 3 means how long more sub CAs we can create. Okay, that's what your properties or attributes decided. Your capabilities. Okay, so whenever you create a whenever CA, doesn't matter your root CA or any CA. So whenever CA signed any certificate, while signature, they also add these attributes. Okay, attributes. Which attribute? Can you become a CA? CA true. Or no, it is only for server, CA false. Or if you become a CA, how much chain you can create further? Path and 0 means you can't create more CAs. You can only sign other server certificate only. There's the attributes we can set. So according to our plan, okay, we have a root CA, but this root CA is going to sign the CSR of what your sub CA. Okay, where root CA is going to tell while signing and becoming final certificate and say these two properties, that you can be a CA, true, but you can be a sub CA or an intermediate CA, but path length would be 0. Means after you won't able to get some more sub CAs. After you can only able to sign the final servers. Okay, that's what I want to perform here. And for this, okay, while signing the certificate, who signed? Your root CA will sign the sub CA certificate. They have to type this property. How? So they will type this property in the configuration file. So I'm going back, guys, to my root CA folder over here. Okay, and root CA is the one who is going to sign sub CA. So the root CA configuration file, this is a config file for the root CA. Okay, these are the properties we have. Okay, so one property is called CA true. One property is issuer. So these are the multiple property we have. Every property was we grouped together into one section. This is called V3CA. Okay, this is one of the sections we have. Okay, but by chance, guys, in this file we have no section for sub CAs. In this file we have section for root CA. Okay, why this is this section for root CA? Because this line makes CA true, means whenever you sign the certificate, and if you use this extension or this section name, then you become a CA. But there's no path length property here. It means you can sign more, we can create more and more sub CAs. Okay, more and more sub CAs. So by default, if you see there, there's no path length property. Okay, so if you want to do this concept I was talking about, so what you have to create, okay, I'm going to create my own custom extensions. Extension means this kind of name. You can give any name, whatever you feel like, my, hello, anything you can give here, or maybe my sub CA, okay, or maybe V3 intermediate. You can give any name, but I'm going to give this name here because this is a very standard name in the market. I'll go see it. Okay, you can give any name, doesn't matter. So this will be your extension name. What is user extension? I'll tell you in a minute, one more time. Okay, or your section name, and here you can customize your own properties. Okay, so one of the property that I would like to use is exactly same. Let me copy from here. 1, 2, 3. These lines I'm going to copy. All the 3 lines as it is. And if you remember in the last class, I used this extension name actually while creating my root CA. Okay, but here I'm going to use the same property. But everything is same. I'm not going to change anything. I am going a certificate that is signed by this extension has a capability of issue certificate. Any certificate who are going to use this extension work like a CA. Okay, but here I want to only enable one property for some reason, nothing very technical, comma is called path length :0. Means any certificate that's called CRT signed by this extension can become a CA, or I can say the intermediate or sub CA. They can issue the certificates, but they can't create more sub CA underneath. Okay, they can't create more chain. Okay, because path length is 0. That's what the line means. So this is just extension name or a section name. So while creating a certificate or while signing the certificate, if I use the extension, so these property automatically added inside the certificate while signing. I'll show you while after we create. So this is what I created here. Okay, inside root CA, why in the root CA? The root CA is going to sign a certificate. So root CA need this extension while signing. So how root CA is going to sign? So for this, we are going to use this command. So I'm root CA. I'm going to sign a certificate. And because I'm CA, I'm going to sign a certificate. Then we have to use a command called CA. When you use this option, it means I'm a CA and I'm going to sign a certificate either for server or either for other sub CAs. But my configuration file I'm going to take, where I have like lot of before settings is, sorry, config file is this. Okay, this file I'm going to use. Okay, and for signing, okay, when you sign, it becomes final certificate because CRT. You all want to use a certificate for the server or for the sub CAs. So here extension will decide. Okay, So extension is a keyword that decide the certificate that you're going to sign finally. The purpose of certificate is just for the server perspective or sub-CA perspective. So here my extension would be this one that I already created. It means the certificate I'm going to create or sign will use this extension that I created, and this extension say you are not the server certificate, you are sub-CA, but only one path. Means after you can't create more sub-CA, and you won't only able to sign the server certificate only. That's all. That is the meaning of the extension. Okay, from where you will get the certificate to sign. So here I'm going to take the input and I'm going to sign my sub-CA certificates. Right now, guys, I'm inside the root CA folder. I'm going to use root CA configure file. Okay, but I'm going to sign my sub-CA, and my sub-CA guys certificate I already keep into the folder called PK, I believe, in the sub-CA, and the certificate name is called sub-CA.csr. Okay, so this certificate I am taking input, and output will be the signature, right? Final sign. So again, I'm keeping into the same folder PK as sub-CA. After signing the CSR, I'm copying the certificate in the same location with the name of CRT. Let me go to my root CA folder, and let me copy this command till here and test. Okay, and number of days I'm going to use, let's say, for 365 10 years I'm using here as the number of, because the normal CA certificate expression normally in years and years mostly. That's all, guys. Okay, so finally, okay, root CA is now finally signing the sub-CA certificates. Okay, by considering that root CA is been known by everyone. In my case, my last I created a root CA by ourselves, but let's say root CA known by everyone. So that is then root CA say I know I am trustworthy for every client in the world. So if I can sign you as sub-CA, then other guys will believe on you also. That is the main purpose. Okay, so let me save this. One error gonna come up here is and when you sign your CA, when you sign a certificate, okay, because this command can be run by anybody, right? But if you're root CA, if you're signing somebody's certificate, how we know you are root CA? So your identity comes from a private key. So where your private key, we don't know. Technically, we know this private key is there in this folder. Okay, but according to configuration file, they are finding the private key in this location. So root CA, guys, in my last class, I created a private key in this folder with this name, right? This is what we know. Okay, but by default, in your CA, you have to use this configuration file. And this sort of configuration file, if you see the initial line, they will tell you when you sign a certificate, we are going to use a private key, and the private key we are going to use is this one. Okay, but in my case, private key name is not this one. My private key name is the private folder only by chance, but the name of the private key I created in my last class is this one. Copy and paste. And guys, this is one of the use of the configuration file. Okay, to tell where your private key located and where you want to keep some other things also. Otherwise, in the command line, you type everything where the private key located, the command become very big. So you are in the root CA, you tell root CA that when you sign, you need your private key located here. So go and pick the private key from here and then sign. Okay, so this was the error they were talking about. So when I sign this, because this private key root CA in my last class, guys, I already logged. So unlock this, and now everything is good. They say I'm going to sign this certificate. Okay, and signature okay. And this certificate I'm going to give a number 1. If you guys remember my last class, I created one serial file. Okay, and from there I write the number 0 in the file. So means the use of serial file I told you my last class is when you sign anybody, okay, every certificate you give a number. Okay, a number you can decide. In my last class, I have given the serial number file 1. So this certificate, first certificate is signed by your root CA. So automatically the number is become 1. Okay, do you want to sign? I say yes. Really? Yes. Confirm? I say yes. Now, this is the first signature sign done by root CA. I'm in the root CA folder only. Now, if you see here, okay, last time if you remember my serial file, guys, I stored number 1, but now it become 2 automatically. Why? Because 1 certificate will already been signed, and that number certificate has been given as serial number 1. And if you notice, last time if I created a file with index empty file, but now if you see this file is not empty, this file is used to store the database. Okay, and what they store, that you are the root C, you sign 1 certificate with the number 01 serial number, and you sign, okay, of which subject you sign a certificate of this subject, means for the sub-series. This is a certificate you have signed. Okay, and one more thing, guys. Okay, last time I created a new cert folder. Okay, but if you go to new cert folder, now this folder contains something. Last time it was empty, but it's under 1 thing. So whenever a root CA or any CA sign anybody's certificate, they create a copy of the certificate in their own new cert folder. Okay, so right now we have signed 1 certificate. Right now in the root CA signed sub CA certificate, but the certificate. So they copy 1 copy just for future purpose. Maybe yes, so maybe not always required. Okay, but they create a copy of the one who have signed either sub CA or the server certificate into this folder called new certs over here. Okay, so that's how they work here. So finally, certificate has been signed, and according to our command, okay, this certificate has been signed and keep over here. So if I go to this folder called PKI sub CA, this is the final certificate. And guys, this is a certificate belongs to one computer. By chance, this computer is sub CA, but this computer certificate is signed by root CA. And how I know? If you try to open the certificate, any certificate that is signed normally has a format called X509, and try to take the data from the CA and try to convert to text format. So now this time what you will see in this certificate, this is called sub CA signed certificate. Okay, what you will see in this certificate, you will see one interesting difference. The difference is this certificate is a subject belongs to sub CA. Okay, but this certificate is issued by some other CA known as root CA. It's like a chain. The way I explained to you, if you see any of the website, let's say this website, okay, if you see in the secure connections, you see over here, okay, this kind of path. The root CA, the sub CA. So Sectigo is this kind of name, and user trust RSA certificate authority is this name. This is how we have created here. And certificate okay means not expired till date. Okay, and one more thing, guys, in this certificate, okay, we have added an extension. The extension, if you see here, is this one. X509 V3 extension is what? This certificate is CA true. And this certificate belongs to anyone, right? That anyone can work as CA, they can sign some other certificates. But because the path length is 0, it means they can't sign some other sub CA certificates. They can't create more sub CAs. because path line is 0. We can't create more path, means chain is stopped here. But they can sign LCA as server certificates. Okay, that was the meaning of the extensions, right? It means this is what we have created. So step number 1 we have did already in my last class. Step number 2 we have done today. Sub CA certificate has been signed. Now is a time to create third step called web server and then sign it for it. But before I create a web server, I have to make my sub CA is complete CA. Now sub CA has the private key, sub CA has their own CRT. Okay, but sub CA need to do their own config file to be updated. Okay, and what to update in my config file? Okay, so let me open this file, guys. This is again the same setting what we did in my last class. According to the conf file of the, because you may be sub CA but you work like a CA, right? So you should have your own serial file, you should have your own index file, you should have your own new cert folder where your private key copied. I just want to know where your certificate copied. I would like to know about this. So this information I have to know. Okay, so we have to update this file. So first of all the certificate will store in a folder, this one. So technically my folder of sub CA is this one. So everything about my sub CA I'm going to store in this folder. Okay, so my according to my configuration file, everything about my sub CA is stored in this folder. Okay, because your CA, either you will do your own self-signed, but right now technically you're sub CA, so you normally get the certificate signed by your root CA. So where your certificate copy, you have to copy put here. You have to create a folder called certs. So in this folder, inside this folder, to create a sub one folder called certs, and your certificate, okay, will be copied there inside this folder. Okay, or technically your certificate will be copied directly here also, dir. So which certificate you have to copy here. Okay, so my certificate is this one, this certificate CRT. So either you create your own certificate self-signed, or you can get certificate from your root CA signed. Wherever you are, you have the certificate, you have to give this name. So my certificate, okay, or the CA certificate that is signed by some other root CA, there's a different point, but where it is, give the path. In my case, the certificate in this folder, and this folder is this folder. Wherever you are, you write this. Okay, then you have to create this file empty for index and this file for serial number. So you are the root CA, and for this, when you're trying to sign first certificate for obviously for a server, then that certificate number will have number 0, 1, 2, 3, or you can give some random numbers also. Okay, and whenever you sign first certificate, their data will be stored in the file called index.txt. Right now everything is empty. Okay, why this file only index.txt? Because it is written. Or you can change the name if you want. The life for database for certificate you sign. Or when you sign a certificate, you will create a new certificate. The default place for the new certificate will be new certs. Because this is the exact same setting what we did in my root CA concepts also. That's what I created. Okay, this is created, this part done, this part done, this part done, this two part is done. Only one thing is private key. When you sign, you need your own private key. So your private key is there in the folder with this name, this one. So you have to give your private key. Okay, so in our case, my private key is there in the private folder only, but the name of the private key is this one. Okay, that's all. So you are a CA, maybe a sub CA, but this is some basic default settings you have to create. Okay, you have to create. Right now, there is no use of CSR file. If you want, you can remove it because this already been signed, become a CRT. CRT is what we need always. This file, if you want, you can remove also. Okay. So if you want, let me remove it. CSR, there's no use of it. Because this certificate we send to root CA, they sign it, they give you back this. So this is what we need. Okay. Now your sub CA has been configured. So has been configured. Now this sub CA is ready to use for signing some other certificate. Now in our case, what we would have to sign, I will have to sign my server certificate. Now we are going to configure my server. So let's do this step. This is very simple. Okay. So I want to configure my web server. And this is software we can use and we can install it. HTTPD software to configure Apache web server. But you can use Nginx, you can use a mail server, you can use LDAP databases. Doesn't matter. The step is same. Okay, for making the encrypted. So the software has been installed, and let me start my services. Start HTTPD. Service started. Let me put some of my web pages here. Okay, this is the folder where we keep our website web pages, or we host the web page from here. Okay, let me create over some index.html, some HTML data. And here I'm going to create some HTML form, guys, just for testing something. This is a pure HTML. And I'm going to ask your password. Okay, input, maybe type, maybe password. You can't see the password, or let me store the password in a p variable. Okay, and this is done. Then you can submit this form by putting your password, type submit, and we submit. My data will go to some pages with a method called post. You can't see the data. That was in my last initial class also. It's a pure HTML, or let's say this welcome message. Welcome to Linux world. It's a pure HTML code we have created here very quickly. So if you want, you can just copy this code if you don't know HTML. Okay. Now, anybody who know the IP address of this computer, or the public IP address in my case. Okay. So by chance, I have hosted this system in my cloud. So I have the public IP. Anybody who know public IP, they can type this IP and they can see this form. Okay. Right now, if I'm typing some password here, is not visible. Okay. None of the places visible. Okay. But I show you my initial classes of cryptography. With the help of WireShark, we can very quickly capture this password. Very quickly, let me show you one more time. But today is a time. It's been a long journey, I know, but today is a day where I am going to show you. I'm going to show you how to make this part, being one minute, guys. I just disable my how to make it secure. But I know this is a pure encryption. Okay, what I'm doing right now, it's a pure clear text. A lot of interface I have, so multiple admins setting, because this is very dangerous stuff to capture the data. Okay, so let me capture my Wi-Fi card. Yes, they're coming up. And now if I only capture this IP address traffic, so IP address. So this is what demo I show you in my initial class also. You guys see we are using HTTP, right? It's not HTTPS. HTTP, it means your data will be clearly visible, right? So let me fill my data one more time. There's a very high level password I'm putting here. Okay, and submit. Data go to server somewhere, and a lot of packet is coming up. But if you see this post request, okay, here from my laptop, this is my laptop IP, I send data to here. And what you see in the post request, you can see your data and your password. I type the password Red Hat right now. Exactly same gonna come up here. It's a pure clear text, right? Why? Because it's not secure. It's a pure unsecure website, HTTP. But we have the web server. But if you try to run the web server with HTTPS, okay, HTTPS, it won't work. Okay, because my site is not HTTPS, and that's what the plan is. Okay, so I want to make my website HTTPS. Okay, so but step number 3 has been done. We have the web server running. Now, only thing from the 3 to 4, we have to convert HTTP to HTTPS, make it secure. Okay. Now, what to do for this? That's what the some steps. Almost a similar kind of steps gonna come up, but there's some steps you have to perform. Okay. So I'm focused on the 4th step. So my plan is I have the server. It may be any server, doesn't matter, from load balancers to web server to database server. So you have the server. First of all, you have to create your own private key. Then you have to create your own CSR, signing request, and send to your CA. And they will sign you back and give the CRT. That's all. Okay. So that's what the steps you have to perform. Okay. But I told you, you should remember, if you want to create a certificate, the identity of certificate, especially in server world, is by your host name or the domain name. Okay, or most generally DNS name. Okay, so your server IP may be this one. Okay, but in the certificate you can't type the IP address. You have to give a name. This called domain name. I told you guys there's some attack. If you don't use your domain name, how your server CA can verify you, because mostly they verify with sending the mail or by sending the DNS, by doing something on the DNS entry. Okay, so that is a reason, especially in server world, either web server or mail server, you have to give your domain name. You have to ask your client to access your server with the DNS or domain name, because what a domain name they try or DNS host name they try. Okay, if that doesn't match with the certificate, okay, then it won't work. Okay, so right now my server IP is different with this one, but I need some unique DNS name or the domain name, I can say, or host name, I can say. Okay, for this you have to buy your domain name. Okay, and then in the domain name you write some DNS entry. So I don't want to go for this step. This is not into the part of this training right now, to buy the domain name and do some DNS entries. Okay, without DNS also we can do this testing very quickly. How? Because DNS is normally used by client. Okay, client. So whoever client want to connect to server, instead IP address, if they want to connect to the host name or the domain name, so client, either they can use DNS or client can use local DNS. That's called host file. If you guys know a host file, so every system has their own local DNS. This is called it is a host file. In Mac, Linux, Windows, every system they have. In my Windows, the file is located somewhere here in the PC or in the C drive in your Windows. Okay, in the system 32 folder, in the driver folder. Okay, this is the folder we have, etc. And this is the host file. This is a file type is file. So every OS has this local file. Like in Linux, we have /et/host file. Mac has, and Windows also. Windows located has this file over here. What is use of this file? In this file, okay, you can create an entity that will work like a DNS. For example, this IP address, we can give a name. It is just IP address, then the name. For example, here I can give the name called www. For example, wiml.com. That's all. Okay, this is the name we created, like a local DNS. Okay, just type the name. Now onwards, now if you want to open this website, rather than you type this IP address, it is working. Or you can type the name also, www.wiml.com. Yeah, so working, right? Seeing both the cases is working. Okay, so we can do in this way also. So now technically, for the client perspective, client can call the server with the name or the domain name or the DNS name. So either put your local entry. Let me comment this line because there's also has some same name. Comment also this line. Okay, so client can call this name. Okay, and why is it important? I told you in some of my other classes. All right, name is very important, and while creating certificate, also this name going to help somewhere. Okay, so finally, what we have decided, my server has this name. Okay, vimal.com or www.vimal.com. Who know this? My client know, either by local file or the DNS, however they know. In DNS, they have to buy the domain name or the other things to do that I don't want to do right now. So I keep in the local file of the client. So if you guys also want to connect me, you can put same entry in your local file. Right now, my server in HTTP, you can connect with IP address, but after I convert my website in HTTPS, okay, IP won't work. You have to use my name. Why? I'll tell you in a minute. So clients should know my name and clients should know how to resolve it. Come back to our server. Okay. Now server has this domain name or some IP address, but let's say this is a domain name they have. Now first thing, server has to get a private key. This is the first step. Then CSR, second step, send to CA. That's the third step. And server will send back the fourth step. Then this becomes final CRT. So for this, almost the same steps we have to perform. Okay, so step will be I'll go to same system where my server has been configured. Okay, here I'll go to same folder of PKI. Okay, and I'm going to create one more folder here called server folder. Okay, typically this system is different, this is different, this is a different system, but I'm doing everything in the same system server. And here I'm going to create again one private folder. And I'm going to create a key or private key, gen RSA. Okay, and I'm going to store the key in a server.key folder with key size 4096. And so one thing, guys, CA is signing a certificate very rarely. But server is keep on encrypting, decrypting packet every seconds. Bigger the key size is, it takes a lot of time to encrypt and decrypt. Okay, so it's recommended in the server normally give a smaller size like 512 or 0124 size to improve your performance. Okay, that is one thing. Second thing is normally we store the private key into some encrypted way, but here we don't store because server is a program. Okay, and when the server program run, then server start working on encryption, and server you need your private key in the clear text. If you keep your private key in encrypted way, how can server able to read it? Okay, so when I use this private key in my actual web server and they don't able to read this private key, how can they can do encrypt and decrypt? Okay, or when I use this private key in my server configuration file, when I start the service might fail, or service may ask the password, and because sometimes then anytime the service will ask the password, it will create a lot of other issues at their boot time also. So to make it simple, what I'm trying to tell you is not most of the time it's not good practice to lock your private key in the server. Store the private key in your server, like in web server, database server, in the normal way, in the clear text private key. It's very dangerous, but you have to give some extra security, make your private key non-readable by other user. Nobody can enter server account with some other security you can add. Okay. So this is a one server private key has been created. Okay. Now, what server has to do? Server has to create their own request certificate, right? How same command, open SSL. I'm going to request. It's called CSR. Okay, my key is there in the private folder, so I created somewhere outside. I believe we don't have to keep in this folder. We can put, there's no technical challenge, but it's not good practice in terms of security. You first go to the private folder keep the private key there over here. Let me come out in a server folder. I'm going to create a CSR, means a request certificate. I'm going to take my private key from this folder. Okay, I'm going to get new, and normally guys, certificate contains some hashing algorithm to use, especially for signature and for integrity. And out would be my server.csr. Okay, so this is what guy your server certificate is going to create. This certificate contain public key plus your other details. Your country name, I'm using same. Your state, I'm using same. City, I'm using same. Organism, I'm using Linux World. Okay, or maybe let's say other name. Department, maybe let's say HR, for example. Okay, but the common name is very important. Okay, if you don't give the right host name, it will fail. So you're going to configure the web server, and client is going to connect your web server with which host name. So certificate should have that would be your common name or certificate, or the certificate name or CN, or the common name. If you think this certificate is going to use a server, and server is going to call back client with this host name or domain name. Okay, or whatever domain name you purchase, or whatever domain you have in DNS, or client know your domain name, client going to connect with you with this domain name or host name or DNS name. Exactly you have to type, otherwise it won't work. I'll tell you why one more time, and when I do the demo. Okay, so this certificate has been associated with the unique name or common name, this one. It means because this certificate belongs to server, not a sub root CA or sub CA. So when the client come to your server with this name, and certificate also have this name, then only the certificate can be given to the client. Then they can take the public. Okay, otherwise it won't be given. You can think in this way also. Now this is the CSR certificate. You can see the request. Try to take in to see into the clear text format. Now we can see this certificate is subject to this host name or this domain name. There is no issuer because this is the CSR. Now we have to get this certificate signed. Okay, signed. So who is going to sign? Obviously your CA. With CA, you can use your root CA also. There's no harm to getting signed from root CA. Okay, but root CA guys is very busy. They might charge you more. Okay, that is the reason we have an intermediate or sub CA. So normally we have to sign by your sub CA. So I go to my sub CA system, or I send this certificate to my sub CA, mail them, send them. Okay, and then they sign. So I go to my sub CA folder or system, and then same command will write. Whenever you want to sign, you use a CA keyword. CA keyword. And here they are going to use this conf file. Now, guys, we are going to send a new certificate. What is the purpose of the certificate? This certificate become a root CA, more chain CA, sub CAs, or server certificate. For everything, we have extensions. Okay. So in your CA, you have the configuration file. In the configuration file, you can see there's a lot of extensions available. Okay. One extension is this one. That is mostly we use in the root CAs. One extension I created by myself, that is for intermediate CA. Okay. And one extension we have here for our server certificates. Okay, that you can customize, but by default we already have. That is called this one, USR certs. Okay, what this extension will do, this will create a certificate, but this certificate is only for the server. How we know? When server, the CA is false, they are not working as CA. That's what we can see here. C is false. Okay, plus this extension can also use, okay, for sorry, okay, this one we can use, actually this one. Okay, so this extension we can use for CA false, means you are not CA, means you are going to use certificate for your own server like a web server or mail server. And usage of this certificate is for key cipherment, non-repudiation. Okay, means this certificate that you're going to use is for cipherment, means, okay, that's what we have to do, right? Why we use certificate? To get the public key. From the public key you can encrypt, decrypt, you can do cipher. That's what the purpose is, right? Or we can do non-repudiation, means we guys know what non-repudiation data signature, but typically this means terms I will explain you with one dedicated class I have given on this topic with a lot of practicals. Okay, but certificate will going to use this extension, means any certificate with this extension means they will work as a server certificates. Okay, I'm going to use this extension, or maybe you can customize also the way you want to customize. Now I'm in my sub CA, I'm into the sub CA folder or sub CA system. I'm going to sign a certificate. I'm CA. My configuration file I'm going to use is Open SSL, and extension that I'm going to use is this extension I would like to use. This may be extension or extension, whatever it will be. Okay, and this certificate I'm going to sign for, let's say, 1 year only. Okay, and here I'm going to take the input of the certificate from my server CSR and going to out the certificate into same location. This goes server.crt. That's all. So almost similar command, guys. There's more changes we are doing here. Command is bigger, but there's multiple times we repeat already. Now this certificate has been signed by, this is your final server certificate, web server certificate signed by sub CA, okay, or the intermediate CA. Okay, so hit enter. They ask the private key of the sub CA. I enter. They say I am the sub CA going to sign the first certificate, so I'm giving serial number 1, and subject would be the certificate belongs to department HR and belong to a server that has a domain name, this one. They are not the CA, they like a normal server. You want to sign yes and yes. Okay, and now you can see automatic serial number becoming equals to 1 to 2. Okay, and you will see index file is updated with one more certificate in the sub CA. Okay, with this belongs to this domain name of this company. Okay, and this certificate we already copied in this folder. So let me go to this folder. Okay, and if you try to open this certificate to see it, so it's X509 format. I'm going to go in this certificate for CRT and try to convert into text format. And what you will see, this certificate issued to my server. Okay, and issued by sub CA. Okay, and what certificate content, guys, that's what I'm trying to tell you in my first day. Okay, your certificate contain your public key. That's what I have to distribute to my clients. It contain your company information, especially a domain name of the server, your validity of the certificate, expiry, or who signed it, your CA. Okay, because if you don't give a CA name, how your client from the laptop or mobile phone browser, they can verify that is the CA be known or not. Okay, is will be covered here. Okay, so now this has been done, right? So finally, guys, fourth step is also be done. We have in my server, we have my own private key and my certificate. CSR now we don't require. If you want to remove, you can remove your CSR file. So we have the server private keys inside this folder, and we have a server certificate. Okay. Now this CRT or private key, let me list also. Okay, let me run the tree command. I don't have tree command right now. Let me install tree. Okay. So what I'm trying to tell you, in this folder, if you run the tree command, okay, they can see the proper formatted folder. So we have a private key and we have the certificate. Now it's your choice where you want to use this, in the web server, mail server, LDAP server, database server, you're into applications, load balancers. Okay. After this, wherever you want to use this certificate and private key, you can use it. Okay. After this, the remaining setup would be your server oriented. Every server will have a different way to put this key and the certificate in their own configuration file. But till now, the step is same. After this, however, whatever the configuration file they have, or inside the configuration file, what kind of keyword they support, you will use their respective keyword to add this key and the private key. What I mean by this, let me show you one demo. Before this demo, I want to show you a test server in the test client. What I mean by this, let me open one more command line terminal. Let me open one more command line terminal, and I'm going to use this one more time, logging to the same server. That's how I did this one in this case. So guys, to test your current setup. Okay, so think this is your client and this is your server. This is your server and this is the client. Okay, to test your private key and public key is working fine or not. So how to test? Okay, to test this, what I'm going to do here right now. Okay, I'm going to create a dummy server here. How in OpenSSL command, they give you option to create a dummy server like a web server with an option called s_server, through which we can create dummy server. Okay, and mostly guys, if you create a web server, and if web server work on HTTP, they work on port number 80, and the web server work on HTTPS, they work on the port number 443. You can change, but 443 is a very standard port. So we can add a keyword called accept 443. So I'm going to create a web server here to test. And this is the web server. So there's a keyword called web, www. I'm going to create my own web server. I have one this web server work on my encryption. And for encryption, I'm going to give my private key that is there in my private folder. This one, this is private key. Okay. And because you're working on the encryption, you have to give your certificate. So for certificate, I'm going to use cert keyword, and this is my certificate here. I'm giving here. So your web server, you're giving your private key, you're going to give your server certificate. And because you're going to give a certificate, you have to also give your CA certificate also, who signed it. So there's one option called CA file, who signed it. So in my case, it is signed by sub CA, and your sub CA has been known by their certificate. It is there in my case over here, I believe. Okay. So whenever you use any server, there's a one dummy command to test. Okay. You have to give your private key to a server program. Okay, like web server. Or you have to give your certificate signed by some CA. And who signed, you have to give that CA certificate also. Now I run this program. Okay, I run this program. So there's a error come up, is key too small. Okay, why small? Why the key is too small? It shouldn't be. Let me check this command. Use certificate E key too small. Maybe guys, in my server, when I create a server, I give a very small key. That might be the reason this command is throwing the error, I believe. Okay, because when you create a server private key, that time I might have given a very small key size of 1024. Maybe this command has an internal setting. If you have to, the setting would be something like this, that you have to give your server private key bigger in size. Okay, that might be the error. So let me do one thing very quickly. Let me rerun this code. Okay, to test this, let me create one more time this server private key and do the same thing again. But this time, let me try with the bigger key 4096. Okay, the private key changed. So obviously, you have to go to your subC, create a new certificate. Sorry, you get a new certificate again. Your private key changed, so your CSR will also change. Okay, again, India, state Rajasthan, this is Jaipur, this is Linux World, this is HR department, host name is very important. Gmail.com. When we started putting into our web server, is created, and let me do last step. The last step would be again sign it. The technique, there's 3 commands to do always the same. So here I'm going to my subCA and going to type this command again. Best. Okay. Because here they see this certificate already available. All right, so they are not going to sign it for us. Check out the okay, already available. So let me do one thing very quickly. Let me delete this file. Okay, file has been deleted. And let me run this command one more time. 1 minute. What is the issue here? RM index. Let me create this file again, index.txt, and my new file. I'm just trying to clean everything so I can do it very quickly. Even though I'm just running this OpenSSL test command, but if you put the certificate what I created into your normal web servers, it will work. Okay, and does they have any other places they have the entry? Let me start serial number also from 0. I'm start setting everything clean. Okay, I'm resetting everything. That's what I'm doing here. New source, clean, nice. That's all. And also removing this my serial key old file. I don't want anything to be conflict here. Best. Not this one, this command. How I signed it. Yeah. So it's been done. Same thing will created. So now PKI server is being again created. Okay, I don't need the server CSR. If you want, you don't remove, that's your choice. Okay. So again, same point. We have a private key and public key. Now this kind of key size is bigger. Maybe my test program will run. Otherwise, doesn't matter if you give the key size of 512 also. In a normal web server or other servers, it will always work. But I just want to try to tell you this extra command for your knowledge. So let me run this command one more time to run our personal test web server. This command. Let me copy this command again. Okay, and that's it. Yeah, it's working fine. So there was only the issue, guys, of the key size, private key file size smaller. only because of this command need at least, I think maybe 2048, maybe minimum they need. So this is the actual test web server started on port of 443. Okay, to test everything work fine or not. And for testing, I have to go to this side. Let's say this is your web server, this is your client, this is your client. How can we test from the client? Okay, to test from the client, what can we do? Okay, we can use curl command, that's all. And right now both the guys are running locally, so I can run local command. And by default, guys, curl command work on HTTP on port number 80. Okay, so this is the output gonna come up. This is my local website, other website output come up. But if you want to work on 443, because they are right now they're working on 443, and this is the encryption website, so it will be HTTPS. And in this case, what you will see? Something fail. Okay, unable to work. Guys, this side, this is my server, right? Okay, and this side I have the client. Okay, client is throwing some error. And if you see the client perspective, they say unable to get local issuer certificate. You know what the client is saying? Client is saying, I am the client. I am connecting the server. Okay, with HTTPS, it means I'm asking this guy, okay, to work on HTTPS. It means I'm asking this guy internally, right? Internally, that I would like to connect you over HTTPS. So by default, the nature of server is they always give a certificate. Internally, server give a certificate to the client. But client, after getting certificate, they give this error. There's some certificate problem. SSL TLS certificate problem. The problem is they say when the certificate come to me, I find a CA signature, but this CA is not trusted. I don't know anything about the CA. Okay, because you're using a sub CA and I don't know anything about sub CA because this sub CA is not trusted. So I'm a curl command, a client line tool. Okay, if CA is not trusted, how can I verify? How can I use public key? And with using public key, how can I communicate with you? If you think this CA is you and you are the one going to use a curl command, okay, you can skip this point. So in the curl, we have an option called key. This key is option given the curl command, the command line tool. Okay, with this key option, what can we tell the curl command? That when any certificate come to you, okay, don't verify the CA certificate, only get the public key of the server, of this server, and do the further encryption part. So encryption can be done, you get the output, but the challenge would be the remaining part of PK won't work, right? It means by chance somebody in the middle attack come up, right? If you put their certificate, you want to verify it. That's a different part. Okay, for that we need a CA certificate to verify. Okay, but I'm not able to verify why. I'll tell you in a minute. Okay, but I can use key options to skip this. Right now, this was the last error. But if I hit enter, now there is no error come in the server side also, and the client side you get some output. So this is some test application they created here, and I get the output. What are they show me as output? This output might be not important for me, but some output come up, and there's no as such error come up. So they show me something as the output of this command. Is a like HTML data come up, and they give some HTML flows. Okay, but I would like to work without K option. That's the main thing, right? If you want to work without K, so I don't need any PKI, right? Okay, K means don't verify CA. If you don't want to verify the CA, then why you use CA? You can use the normal hybrid setup, right? What I show in my initial classes. Okay, in hybrid setup, the issue was any MITM attack can be performed. So I've seen a lot of guys use this key option here to skip the CA signatures. Okay, it's good for initial some basic tested, but it's not actually, you're not actually using the PKI power. You're skipping the CA signatures. Okay. Now this is the better command. It's not working. Now why is not working? Because of one big reason. Okay. Your client doesn't know this CA who signed this certificate. Okay. Why that doesn't know? Okay. Because this CA sub CA is not known to the client. It's not trusted. They doesn't know. They doesn't know about this. Okay. So what to do? Okay. To do this, okay, we have to go to my root CA, okay, and ask client, do you know root CA? And root CA is known by every client. So same root CA is the one who signs CA, sub CA. Okay, so technically what I'm trying to tell you here is, okay, okay, while doing curl, I can say, okay, for curl, you need some CA to be verified, but the CA that has been signed this certificate is not known to you. The CA and the CA name you can find from the certificate also is not known to you. To make the CA trusted, normally you don't able to trust the sub CA, but normally you trust root CAs. Okay, and how you trust root CAs? Okay, because guys, in every operating system, okay, all the root CAs is stored in some folder, and this folder name is called etc pki TLS certs. This folder in Linux, this is a folder name. In Windows, the folder may be different. Okay, every operating system know all the root CA's name. If this certificate is being signed by any of these root CAs, if I try to open any of the file here, CA bundle means it is a bundle of all the root certificates or root CAs actually. If you open this file is purely encoded in this format. But if you see here, all the root CAs name, AC raise or FNMT, all the CAs, ANF secure server root CA, okay, at least whatever root CA would be, okay, all the root Amazon root CAs till date, whatever root CA available that has been trusted by all the operating system is their certificates here. Okay, so any certificate or server certificate that's signed by any of these guys, okay, okay, in that case, curl command won't create any issue. But right now, curl command is not able to verify certificate. Why? But this web server is being signed by this sub CA, and this sub CA is not trusted, or the roots CA is also not trusted. Who signed this? Why? Because the root CA is created by us only, right? How my OS will trust. Okay, either this root CA is being trusted by all the operators in the world, or what can you do for testing this? Okay, your root CA certificate is actually located here in my case, etc PKI, in PKI root CA cert here. Okay, this certificate, if I appended into this file, that's the only thing we have to do, right? This is the only thing we have to do. That's all. Now, this line means this operating system is my client operating system. My client operating system know all the root CAs from this file. And now in this file, I added one more new root CA that has been now become a trusted root CA only for this client operating system because I've updated manually. Okay, is this one. So these are the names. But if you go in the last line of this file, this is what I added right now. This is my own root CA certificate that we created in my last class. Okay, and think now this is your client system. Okay, and now client will try to connect again one more time. Till now, guys, we are facing this error. get some alert in the server. Okay, but this time when I try to connect, you might see different error. This error is gone. This error is gone. Now your client say, which your certificate is coming to me, this signed by this sub CA. I don't know about this sub CA. This sub CA by signed by some other sub CA. I don't know about this sub CA. But what I know about the root CA. And root CA is trusted by me because I put into my this form. So this is where I have all the bundle of root CAs. Because I know root CA, and the signature is verified, and I take the public key. Only challenge is in this certificate. Okay, this certificate that I'm getting right now is been signed by a name vimal.com. I saw you at that time when I get a certificate, that time I signed the name by this name. So any client who want to connect, they can't use any IP address. They can use only the name. Okay. Right now the system doesn't understand this name because this is a different computer altogether. Okay, they might connect to some other vimal.com. So what I'm doing, guys, here for testing, I'm opening this system local file and typing. Anybody try to connect to this IP address, they will use vimal.com. So this is the local file for this system. Now if I try to ping, I'm going to local. Now, only thing is, if you try to connect the website, this won't work. Okay, but you want to connect, you have to write the domain name. Okay, now working fine. See here. Okay, there is no error. This is a server. The client, there is no error, and you are actually successfully connected to the server with HTTPS. There is no error come up, and everything is internally verified by your client side tools. Okay, curl is getting the certificate. They are verifying the certificate by sub CA, then sub CA, then root CA, and root CA they know because they find in the internal bundle. It's called trusted. Okay, and there's been trusted. So this verify signature, they get the public key from the certificate of the system, and the remaining portion will be TLS SSL handshaking they're doing behind the scene. So very, very powerful demonstration this is. So this is what we have tested by this command. Let me do Control-C to stop. And after you tested your public key, private key working fine in the server. Now this public key, private key, after you tested, you can put in your web server also. How? Let me show you this demo very quickly. Okay. Now my web server, what I've been hosted. Okay, while working on HTTP. Now I'm going to convert HTTPS. How can I do? So for this, okay, in your Apache web server or Nginx web server or mail server, every server has their own configuration file. Okay, for example, if you talk about HTTPD, by default HTTP doesn't support SSL. And if you want to enable the SSL, there's one software to install. It's called Mode SSL. This will give you extra module to my Apache web server. So this software gives extra module. Okay. So every guys program will have a different way to configure, but logic wise they are same. Okay. So this software installed, and this software will give us a one configuration file that's located here. Okay. So anybody who know Apache web server, so this is the config folder for the Apache web server, and this is the config file they put over here. Okay. Now in this configuration file, what you have to type, you can type only two things. Okay. First of all, guys, by default, your web server is working on port number 443 on this protocol. This is what we need. You don't have to change anything here. Okay. But if you go down, what you will see, your web server work on 443 port number. In this web server now, SSL engine is on. Now your web server start working on HTTPS or SSL. One more thing, I would like to type server name here. Now our web server work on vimal.com. That's what my client will going to send, because this is what my certificate is. Okay, my web server will get the web pages from this folder, because this is the folder where I have put in all my web pages already, like form. Okay, the very basic settings. For main setting, what you have to do here in the web server is this part. Okay, where your web server certificate, the CRT. Second thing is where your private key located on the web server. And third thing is, okay, where your server certificate located. Okay, so whatever guys I use in my command line, okay, private key, CS certificate, and the server certificate, exactly what your product is also asking. Now it is a web server, load balancer, three things you'd always give your server programs. Okay, in my case, they are located here. Okay, so my actual path is actually this one. Let me capture the actual path. Is PKI server, private, and server. So this is the location, guys, where my private key located. Then the copy. Okay, and I'm typing here that my private key is located in this folder. So this web server going to use this private key, the Apache web server. Okay, my PKI server CRT. So this is the location where my certificate has been located on my server. So CRT means which is server that is signed by your CA. That is this is certificate. Okay, and who signed? Either can give the entire chain of it. Chain means just one file where you put your sub CA, then sub CA and root CA, all the way you can give here. Okay, if you multiple sub CAs, but right now I don't have multiple sub CAs, only one sub CA, but where the sub CA located, their certificate located, it is there in my sub CA or CRT. So this is a sub CA certificate. Okay, so it is, I just uncomment this line in this certificate. Okay, so this is the config file for Apache web server. Okay, load balancer will have different config file, but console-wise they have different keyword. But console-wise they are exactly the same. Keyword will be different, file name will be different, but console-wise they are exactly the same. Now you can control much more thing here. Okay, much more thing here. For example, you can set which version of SSL you support. Okay, much more, you know, which cipher you support. So lots of settings we can do here, but I know this much settings we need to configure right now, the settings. Let me save this file. Okay, and let me restart my service. Because I changed something in the configuration file of server. So let me restart my services. Okay, this will fail service. One of the service reason they may fail because my web server is reading the file from some other folder, and there's one security in Linux. It's called SC Linux. They might stop this. So right now my SC Linux is enabled. So let me stop the SC Linux for a while. SC Linux has no relation with encryption, but right now my web server reading file from some other location. So SC Linux sometimes stops. There may be some of the reason they fail. So let me stop the SC Linux as security Linux and again start. So while my web server again start, we can run the netstart command to check the port number, but port number is started already. Maybe SS command to check the port number, the command available. Okay, so port number 443 has been started. It means my web server is started with HTTPS. HTTPS. Now, any file that I've been hosted in this folder, now my client can access this file, okay, from the command line. Again, let's say this is the client, and client want to access this file. You can see this file come up right here, and there's no error come up, right? Okay, they can use without HTTP also. By default, my web server working on both the port number 80 also work, But here 80, they will send the same data, but internal packet will go purely clear text. But if you use this, okay, data come exactly same, but while transmitting the data, they're coming very, very encrypted. Nobody can break it. Okay, and behind this, a lot of things is happening. And why they work? Because this server is my web server, Apache web server. This is the Apache web server. Okay, using this certificate designed by the sub-CA, and sub-CA is beside root CA, and this system actually, only this system is actually being trusted by that root certificate. Otherwise, it won't. If I remove the root certificate, let me show you very quickly. If I remove my root certificate, okay, is the last line of this file. If I remove my root certificate, okay, from this trusted file, okay, now this root certificate is not known. You can fail. See here. So it's a game of, this is what I told you guys initially. Okay, all the root CA that is signed your certificate or sub-CA certificate, okay, should be known by all the client systems. Okay, and that is the reason they are known as root or trusted. If they don't know, or you can create your own one, there's a different point, but you can make your system trusted, but how your client can be trusted, right? You can create your own computer trusted to your root CA, but other client won't able to trust. So there's a different point. Okay, so this is a different computer, but if I try to do the same thing in my Windows operating system, okay, last time you can see this data in Windows operating system, you can see this page come up. Okay, it means my web server working on HTTPS, but this certificate, even though if you see the packet also capturing here, okay, I hit enter there, and here if we try to see and TLS, I don't know how the TLS data should come. Sorry. TLS. Become very slow because a lot of it has been hit. Okay, so system actually if we start this, it takes some time, but yeah. So when you hit this, why you see this option? Because your browser in Windows, Chrome browser and the Chrome browser say your certificate is signed by sub-CA, but sub-CA is not known by a root CA, but root CA, I don't know who is your root CA because it's not trusted in my browser. You can click on advanced, you can proceed without checking that this option is like a key option, curl key, something like this. Okay, so you can see guys, this is what they are giving to you. So this line is giving your certificate. Okay, all the things stuffs to you. So client, I'm the client, I'm sending hello to you. Hello to you. Okay, and I'm giving handshaking. By since we are working on TLS version 1.2. Okay, and I'm saying I'm a client. This is all the signature and all the things are supported. Okay, and then your servers say hello to you, and servers say these are the protocol I supported, AES or RSA, and these are certificate protocols have I supported. Then server will give a certificate to you. See here, server is the one. This is our certificate. Server has given. I think this is what the different system actually. It's not mine actually. It's actually different systems. But let me check for this system. The same thing will be guys come in the system only, right? But if I click proceed, it is like an unsafe. Unsafe means it is like key option, right? What I explained to you, key in the curl command. It means I don't want to verify CA certificate, right? Without this, I would like to go and pick the public IP and do the further things, right? But it's not at all good. You can see your data, but it is not secure. Why is not secure? Because anybody can do MITM attack. How you know this public key coming from the real server? Somebody might have done some poisoning attack or might have done some kind of MITM attack that I'll explain you very detailed. Okay, anybody can create your own CA also. Okay, so it's like part of MITM attack. But if you see here, okay, the certificate is not valid. And if you see here, by chance you can see the entire set of paths here, sub-CA. Okay, but you're not getting the detail who signed the sub-CA. Okay, why? Because your browser doesn't know about your sub-CA. Who is your, sorry, the browser doesn't know about your root CA. Okay, in this browser, this is a client, but in this browser is my command line tool. They know. That's what there is no error come up. Why they know? In this system or in this client system, in the Intel bundle file, I copy the root CA. That's what they know. Similarly, in my Windows, wherever I have this kind of file that Windows has, if I copy my this file, kind of file in Windows, if I copy my root CA, then this warning error will go. Or if I copy inside my browser somewhere here, you know, in my settings, in my, if I search for certificates, security and security, must try to put here in my trusted root. So if I copy my root certificate here in my trusted root system, okay, which certificate? Your root certificate. Okay, then in that case, in this case, browser won't give this error. Let's say now, because I know this root sub-CA certificate, and thing will work. So guys, if you want to try this demo, I don't want to invest for that time. Okay, copy this certificate, download from the system, put in the Windows, import here, where it is, import here, the name will become up here with the name of your CA, root CA, and that's all. And close this. Then again, if you refresh this page, it is encrypted right now. Even though if you try to read this data from a browser, you won't able to see any data. Last time you can see the data, but now is this time if you try to see any data from this IP address, okay, and why they take a lot of time, but anytime you want to see from this IP address, you won't able to see it. Okay, you won't able to see it. Why? Because HTTPS. This warning only because of the root CA doesn't root your browser doesn't know the root CA. That's only reason this warning is coming up. But everything has been purely encrypted. Wait for some time when the data come up here, you can see entire data what is coming to your browser is purely encrypted. Here from this system, any data they're coming up. By default, guys, right now they're using TLS version 1.3 with the VI configure here. Okay, and this is the data we have. Last time, guys, I show you this entire password. Even though if I try to write the password here, submit. Last time my password has been captured here, but this time you try to see, you can see your data password in this format. This is called cipher data. And nobody can break your cipher data because nobody has your server or the client shared secret keys. Everything being encrypted, sent encryptedly, right? This is what has been set up. So one small task I just want to give you, you can try. Okay, the task is very simple. Okay, I also want you rid of this error. Okay, entire steps I've explained to you. Go upload the certificate here, with certificate, root certificate, and after you upload, when you refresh this page, this error will gone, and you will see one more thing in this secure part. If you go to certificate not valid, if you here in the secure part, you can see the entire path, your server name, then your sub CA, then your root CA. There you can see the entire path of it. Okay, so sub CA is known by root CA, but root CA is not here in this browser. That's what the error is. It only import. Okay, so that's all, guys, from my side.